Good morning, friends. Up to we discuss the numerical of exercise up to 11.12. Right? Now 11.13. All the numericals are very easy. Only the very limited numbers of the equation in this chapter. We are using this equation and we find out the whatever quantity we have to find out. Now 11.13. What is momentum, speed and de Broglie wavelength of an electron with kinetic energy of 120 electron volt? Already we discussed this type of the numerical, but at the time the voltage is given, accelerating voltage is given. We find out first the kinetic energy, and the remaining part is same as this. We find out the kinetic energy K is equal to E into V. That means the charge of an electron into accelerating voltage. Right? So here the kinetic energy is directly given. Now kinetic energy is given in electron volt. Therefore kinetic energy K is equal to 120 electron volt. Convert into joule. Therefore 120 into 1 electron volt is equal to 1.6 into 10 is to minus 19 joule. So it's equal to 1.92 into 10 is to minus 17 joule. That is the kinetic energy in joule. Right? Now we have to find out the momentum. For that purpose, Planck's constant required 6.63 into 10 is to minus 34 joule into second. And also we require the mass of an electron. M is equal to 9.11, 10 is to minus 31 kg. Here is okay. Now first we have to find out the momentum. Momentum of an electron. We know that the momentum P is equal to only mv, but here speed is not given, kinetic energy is given. Right? Therefore the relation between the kinetic energy or the energy and momentum is E is equal to P square by 2m. E is equal to P square by 2m. Therefore P is equal to under root of 2mq. Actually here the relation is E or the K is equal to P square by 2m. How we obtain this relation? So we know that half mp square, right, is the kinetic energy. Multiply and divided by m. So that becomes the momentum. Therefore, p square upon 2m is equal to k. P square upon 2m is equal to clear this? Okay. For that purpose here, directly we are using this relation P is equal to under root of 2mk. Now we substitute the value. All values are given. M is the mass of electron. K is the kinetic energy is given. If we substitute, so we obtain the momentum is equal to 5.91 into 10 is to minus 24 kg meter per second. Not you have to directly enter the answer. You have to substitute the value in this equation. P is equal to under root of 2 m 9.11 into 10 is to minus 31 into k 1.92 into 10 is to minus 17. And as you simplify, you obtain the answer of momentum is this. Now second, we have to find out the speed. Therefore the speed V, speed of an electron. Momentum is found. Therefore P is equal to mv. P is equal to mv. Therefore speed V is equal to P by m. Right? So as we substitute the value of momentum, this 5.91 into 10 is to minus 24 upon m. So m is 9.11 into 10 is to minus 31. So we obtain the speed is 6.5 into 10 is to 10 is to 6 meter per second. Now the C portion is de Broglie wavelength. We have to find out the de Broglie wavelength. We know that the equation of the de Broglie wavelength is lambda is equal to h upon p. Lambda is equal to h upon p. H is the Planck's constant. Its value is 6.63 into 10 is to minus 34. Momentum already we obtained. That is the 5.91 into 10 is to minus 24. Minus 24. Therefore, the wavelength is 0.112 into 0.1121 nanometer. That much nanometer. Clear this? So this way, by using the equation, we can find out the momentum, speed, and de Broglie wavelength of an electron with the kinetic energy 120 electron volt. Okay. Now, after that, so this numerical are important for 3 marks. Now, next is 11.14. The wavelength of light from the spectral emission light of sodium is 589 nanometer. Find the kinetic energy at which first an electron and B and neutron would have the same de Broglie wavelength. De Broglie wavelength of both are same, right? For that purpose here, first the wavelength is given, lambda is equal to 589 nanometer. So 589 into 10 is to minus 9 meter. Right? After that, here for electron and neutron both required, therefore we require also the mass of electron and neutron. Therefore mass of an electron Me is equal to 9.11 into 10 is to minus 31 kg. Mass of neutron Mn is the mass of the proton, same as. Therefore 1.67 into 10 is to minus 27 kg. Planck's constant required at 6.63 into 10 is to minus 34 joule into second. We also require the conversion of electron volt into the joule. 1 electron volt is equal to 1.6 into 10 is to minus 19 joule. Clear this? Now the de Broglie wavelength of electron and proton neutron are same. Here de Broglie wavelength of electron and neutron are same. Now de Broglie wavelength of is lambda is equal to h upon p. Right? But here we have to find out the kinetic energy. Therefore, the momentum must be placed in terms of kinetic energy. So we know that. But momentum P is equal to under root of 2mk. That means the 2 into mass into kinetic energy. Substitute here. Therefore, lambda is equal to h upon under root of 2mk. Making the square on both sides. Therefore, we obtain lambda square is equal to h square upon 2mk. We require the kinetic energy. Therefore, kinetic energy K is equal to, take the K here, h square upon 2m lambda square. 2m lambda square. Now, first, kinetic energy of an electron. That is the K is equal to h square upon 2me lambda square. H, value of h, 6.63 into 10 is to minus 34 whole square upon 2. Mass of an electron 9.11 into 10 is to minus 34 into lambda square. Lambda is given as 589 nanometer. That means the 589 into 10 is to minus 9 whole square. So we obtain the kinetic energy of the electron is 4.35 micro electron volt. So you obtain in terms of the joule. Convert this joule into the electron volt. That is the kinetic energy of electron. Now B. Kinetic energy of a neutron. So directly we can write from equation this one, equation of the kinetic energy. So Kn is equal to h square upon 2m lambda square. Substitute the value the same manner. Only here the change is that instead of the 9.11 into 10 is to minus 34, here we substitute the value of mass of neutron 1.67 into 10 is to minus 27. Therefore, 6.63 into 10 is to minus 34 whole square upon 2 into 1.67 into 10 is to minus 27 into lambda 589 into 10 is to minus 9 whole square. Then we obtain the kinetic energy of neutron is 2.37 nano electron volt. Nano electron volt. So where is the numerical compared to the other chapter? Here the mass of the proton and electron and neutron, we know it, and also the wavelength of incident light given. So we can find out the kinetic energy of electron and neutron. Both have the same de Broglie wavelength, and due to that reason here we take the lambda, value of lambda are same in both equations. Clear? Now next numerical is 11.15. What is the de Broglie wavelength of? Here the three different objects are given. One is the bullet of mass 0.04 kg traveling at the speed of 1 km per second. Second is the ball having the mass is 0.060 kg moving at a speed of 1 meter per second. And third is a dust particle of mass 1 into 10 is to minus 9 kg and deflecting with a speed of 2.2 meter per second. We have to find out the de Broglie wavelength for three different objects. Mass and speed are given. Now we know that the equation of the de Broglie wavelength lambda is equal to h upon p. Right? H is the Planck's constant and p is the momentum. It means first we have to find out the momentum for these three objects, and then we have to substitute the value of momentum in equation of de Broglie's wavelength. For that purpose here, de Broglie wavelength is lambda is equal to h upon p. But we know that p is the momentum. Momentum is equal to mass into velocity. Therefore, h upon m into v. Then the equation 1. Now, first for bullet. What is given? Here, mass of bullet mb is given as 0.040 kg. Speed of bullet vb is given as the 1 kilometer per second. Convert into meter per second. That means the 10 is to 3 meter per second. Therefore, de Broglie wavelength of bullet, lambda bullet is equal to, from equation 1, is equal to h upon mass of bullet into speed of bullet. Now, Planck's constant 6.63 10 is to minus 34 upon mass of bullet is 0.040 into 10 is to 3 is the speed. 10 is to 3 is the speed. Therefore, 1.7 into 10 is to minus 35 meter is the de Broglie wavelength for bullet. The same method we can find out the de Broglie wavelength for ball and also a dust particle. Therefore, for a ball, mass is given m is equal to 0.060 kg and speed of a ball is given as 1 meter per second. Therefore, de Broglie wavelength of a ball, lambda for a ball is h upon mb into vb. But here mb is the mass of a ball and vb is the speed of a ball. Lambda for a ball is equal to h upon mb. So we obtain the value is 1.1 into 10 is to minus 32 meter. Similarly, we can find out for a particle, there is for a dust particle, directly I write the equation value of wavelength for a dust particle, lambda dust is equal to 3 into 10 is to minus 25 meter. Find out yourself by placing the step and value. Clear this? Okay. Now next is an electron and photon. Each have the wavelength of 1 nanometer. Right? Find their momentum. Second, energy of photon and kinetic energy of an electron. Now here the wavelength of electron and photon are same. Wavelength of electron and a photon are same, so that momentum also same. Momentum are also same. Therefore, PE is equal to PP. That means the momentum of electron is equal to momentum of photon. And momentum P is equal to H upon lambda. P is equal to H upon lambda. So here the wavelength is given the 1 nanometer. Lambda value of lambda is 1 nanometer is equal to 10 is to minus 9 meter. Therefore, momentum of electron is equal to momentum of proton is equal to 6.63 10 is to minus 34 upon 10 is to minus 9. 10 is to minus 9. Therefore, 6.63 into 10 is to minus 25 kg meter per second. Be the momentum of electron and photon. Right? Now, B part. What is the energy of photon? The energy of photon is energy of photon. E is equal to hf. but the frequency not given. So instead of the photon, we can frequency we can add as c upon lambda. S is the Planck's constant, 6.63, 10 is to minus 34, C, 3 into 10 is to 8 upon lambda. Lambda is the wavelength, 10 is to minus 9. Thus, we obtain the energy of photon is 19.89 into 10 is to minus 17 joule. Convert into electron volt, so divided by charge of an electron. So we obtain the 1.243 kilo electron volt. That is the energy of photon. Where is the equation from the characteristic of photon? E is equal to hf. Here frequency is not given, but wavelength is given. Therefore, substitute the f is equal to c by lambda. And we substitute the value, we obtain the energy of photon in joule is this, 19.89 into 10 is to minus 17, and energy of photon in electron volt. That is the 1.243 kilo electron volt. Now see, kinetic energy of electron. Already we know the momentum of an electron. So already we know that the relation between the kinetic energy and momentum, E is equal to p square by 2m, or the k is equal to p square by 2m. Therefore, kinetic energy of electron Ke is equal to p square upon 2m. P is already found, that is the 6.63 into 10 is to minus 25 whole square upon 2. Mass of an electron 9.11, 10 is to minus 31. Thus, we obtain the kinetic energy is 2.415 into 10 is to minus 19 joule. And also in electron volt divided by E. So we obtain, that is the 1.51 electron volt. Clear this? Again, an electron and photon each have the wavelength are same, that is the 1 nanometer. Wavelength are same, therefore their momentum also same, because we have the equation of de Broglie wavelength lambda is equal to h upon p, therefore momentum p is equal to h upon lambda. Therefore the momentum also same. Therefore p is equal to pp, momentum of electron is equal to momentum of photon. So 6.63 into 10 is to minus 34 upon. Wavelength is 10 is to minus 9, because the wavelength is given as the 1 nanometer. 10 is to minus 9. Thus we obtain the momentum of electron and photon is 6.63 into 10 is to minus 25 kg meter per second. Now in B part, the energy of photon. From characteristic of photon, the energy of photon is equal to hf. But the frequency not given, wavelength given, therefore we transfer the frequency into wavelength by replacing the f by c upon lambda. Therefore the energy of photon is in joule 19.89, 10 is to minus 17 joule, while in electron volt 1.243 kilo electron volt. Now, kinetic energy of electron. So, kinetic energy Ke is equal to p square upon 2m is equal to, already we found the momentum of electron 6.63 into 10 is to minus 25 whole square divided by 2 into mass of electron 9.11 into 10 is to minus 31. Therefore, kinetic energy in joule 2.415 into 10 is to minus 19 joule, and electron volt is 1.51 electron volt. After that, the next numerical is, for what kinetic energy of a neutron will the associated de Broglie wavelength be 1.4 into 10 is to minus 10 meter. So in first part, we have to find out the kinetic energy of neutron. Right? For which the associated de Broglie wavelength is given. Therefore, we can add from this de Broglie wavelength. So lambda is equal to h upon t. But here momentum is not given. Kinetic energy we have to find out, that means we have to substitute the value of momentum in terms of kinetic energy. Wavelength is given here. But P is equal to under root of 2mk. 2mk. Therefore, lambda is equal to h upon under root of 2mk. Therefore, lambda square is equal to h square upon 2mk. Therefore, kinetic energy K is equal to h square upon 2m lambda square. Now, value of lambda is given. Substitute the value h square 6.63 10 is to minus 34 whole square upon 2. Now for neutron, the mass of the neutron is same as the mass of proton. That means the 1.67 into 10 is to minus 27. Lambda square, lambda is given 1.4, 10 is to minus 10 whole square. So thus we obtain the kinetic energy of the neutron is 6.686 into 10 is to minus 21 joule. Or in other words, in electron volt, 4.174 into 10 is to minus 2 electron volt. That is the kinetic energy of neutron. Again, for what kinetic energy of a neutron will the associated de Broglie wavelength be 1.4 into 10 is to minus 10 meter. Here the de Broglie wavelength given, we have to find out what is the kinetic energy of neutron. With this kinetic energy, the wavelength of the neutron is this. Therefore, lambda is equal to h upon p. But the momentum is in terms of the kinetic energy is under root of 2mk. We substitute here lambda is equal to h upon under root of 2mk. We require the kinetic energy, therefore making the square of both sides, lambda square is equal to h square upon 2mk. Now we require the kinetic energy, therefore k is equal to h square upon 2m lambda square. We substitute the value. H Planck's constant 6.63 10 is to minus 34 whole square upon 2. M is the mass of neutron. Mass of neutron earlier numerical we take, that is the 1.67 into 10 is to minus 27. Because the mass of neutron and proton are same. Into lambda square. Lambda is already given 1.4 into 10 is to minus 10 whole square. If this simplified, we obtain the kinetic energy is 6.686 into 10 is to minus 21 joule is equal to 4.174 into 10 is to minus 2 electron volt. This kinetic energy in joule is divided by charge of an electron, we obtain in electron volt. Now, B portion. Find the de Broglie wavelength of neutron in thermal equilibrium with the matter having an average kinetic energy of 3/2 kBt at 300 Kelvin. Now, average kinetic energy of neutron is K average is equal to 3/2 kb into T. Here kb is Boltzmann's constant. Boltzmann's constant. Its value is 1.38 into 10 is to minus 23 joule per mole into Kelvin. Mole into Kelvin. Here T is given. T is 300 is given. Therefore, first find out the average kinetic energy, or directly we substitute the value of K average. So 3 by 2 kb is 1.38 into 10 is to minus 23 and temperature is 300. So we obtain the kinetic energy is 6.21 into 10 is to minus 23 joule. That is the K of waves. After finding the K of waves, we require the de Broglie wavelength. Therefore, de Broglie wavelength is lambda is equal to H upon under root of 2m K of waves. Now, de Broglie wavelength is equal to H upon under root of 2m K of waves. Substitute the value, so we can obtain here 0.146 nanometer. 0.146 nanometer. Yourself substitute the value and simplify, we get this answer 0.146. Now this relation, kinetic energy is 3 by 2 kb into T, already you learn in properties of the gas. Right? 3 by 2 kb into T, kb is the Boltzmann constant, this value keep in mind that 1.38 into 10 is to minus 23 joule per mole Kelvin. First find out the K waves, so K wave is this. After our equation of the de Broglie wavelength, this equation, lambda is equal to H upon under root of 2m. Here, kinetic energy is K waves, already we found this. So we obtain the de Broglie wavelength is 0.146 nanometer.